Hello everyone, today we will be providing additional material about the common failure that may occur with robots in general and specifically the Vex IQ kits and how you can address them. The failure often occurs due to parts breaking or malfunctioning. A common reason parts break or malfunction is due to too much stress on the part. What is stress? Stress is the force applied to something times the cross-sectional area of the object. It is also known as the force per unit area. When excessive stress is applied to a rigid body, the body will begin to deform, and those external forces generate internal stress, which could lead to deformation like a crack. Scientists and engineers measure these deformities as a measure of an external force across the cross-sectional area of an object. There are two different types of stress and that structure may undergo. The first of those is traditional normal stress, in which a force acts normal to the surface of an object. For example, when you press your foot down on the pedal of the bike, you're applying your force perpendicular or normal to the surface. The other type of stress is shear stress, that acts parallel to the surface of an object.
One part that may break due to excessive stress is pins. As you might have seen through the construction of the robots, there are many joints and parts that are connected by pins. Pins can break due to an excessive force that is applied over the small area of the pin, and can also break due to misplacement of the part, such as a mechanical defect of the pin. However, there are ways that you can mitigate the stress that the pins undergo. One of those ways is increasing the number of pins in your structure. When your structure has a greater number of pins across it, each pin supports less weight or force, meaning that each pin can carry less force, which could reduce the number of deformations of your designs. When operating with the Vex IQ smart motors, there are a series of different situations that can occur when the motor acts in a different way than how it should. If the smart motor turns when it shouldn't turn, or if the motor rotates in the wrong direction, apply the following steps. Begin by pairing the Vex IQ robot brain with the Vex IQ controller and running the driver control program. From there, you will review proper configuration of the driver control program and the attached worksheet to ensure that the smart motor is wired to the correct smart port. If the smart motor turns when the controller is not being pressed, please reference the sheet on the following steps to troubleshoot the solution. If the smart motor turns in the wrong direction, check to see if the configuration of the smart motor should or should not be reversed. If running a user program, check the program for possible errors that might cause the smart motor to move incorrectly. If the smart motor does not move at all, check to see that the smart cable's connectors are fully inserted by pressing until an audible click is heard. Try replacing the smart cables with new ones as well. If there is now an error message, but the smart motor is properly connected, review the How to Fix Displayed Error message on the Vex IQ brain. If the smart motor is detected as a bumper switch, try replacing the smart cable with a new one. If you are still seeing errors, check the smart port on the smart motor and robot brain for bent pins or debris.
When connecting sensors or actuators to the Vex IQ brain, you have a lot of options. All 12 of the labeled ports are usable with all Vex IQ sensors and actuators. When connecting a device, make sure to select an appropriate length cable, long enough to stay connected through the device's full range of movement without too much extra cable to get stuck on something. If a cable or port does not seem to work, try replacing the cable, trying on a different port, or trying a different device with the same cable and port to diagnose which one of these parts has failed.
As you begin to program with the Vex Code IQ, motor blocks will not appear in the toolbox until a motor has been configured. There are various options that you can do to configure a motor, which include adding a motor, changing a motor's port number, naming motor directions, renaming a motor, reversing a motor, or deleting a motor. To add a motor to a system, you should first configure the motor by selecting the Devices button to open the Devices window. From there, add a device, select Motor, and select which port the motor is attached to on the Vex IQ brain. If a port is already configured for another device, it will be unavailable. Once the motor has been configured, select Done to submit the new device configuration. You can change the port number for the motor by selecting the motor in the Devices window. Now, select the plug icon in the top right corner of the Options screen. Select the port on the port selection screen, and the port number will turn green. Then select Done to submit the change. In the Options menu, you can also rename a motor, reverse a motor, or delete a motor using similar procedures, which will be detailed in the reference sheet.
When the brain is first connected to the Vex IQ software, none of the sensors will show up, and you will have a blank Vex code project. To add and configure the sensors, follow the steps detailed in the linked Vex article discussing the procedure of configuring the sensors in the Vex IQ software. It may be helpful to rename sensors so that they each have a specific name as to not lead to confusion about which sensors are being referred to in the code. When configuring the sensors, make sure that the sensor is registered to the correct port on the brain so that the Vex IQ code will be able to interact with it. If the sensor is registered to the wrong port, the Vex IQ code will not be able to recognize it, as it'll think it is either not connected or that it is a different sensor that is assigned to the port that it is plugged into.
To turn on the Vex IQ brain, insert the battery into the back of the brain. Then, press the check mark button to turn it on. To power it off, hold the X button until the screen turns black. If the robot brain is frozen and will not turn off by holding the X button, the battery can be removed to force the brain to turn off. If the brain does not start with the check mark button, check if your battery is charged.
We'll now go over charging the Vex IQ brain battery. Before you have the students start assembling the kits, you want to make sure the Vex IQ brain battery is charged. The kit should come with the brain battery, a battery charger, and the charging cable. To charge the battery, you need to attach the charging cable to the charger, plug it in, and then place the battery in the charger. When you plug it in, you should have a solid red light turn on. This means it is charging. Once the light turns to a solid green, this means it is fully charged. To maintain the battery life to the best of your ability, you can do some things to make sure it lasts. This includes charging the battery whenever you're not using the robot, make sure a backup battery is always charged, and disconnecting the battery from the IQ brain whenever the robot is not being used. If the charger is blinking green, this means the battery is overheating. Remove the battery from the charger and let it cool for a little bit before replacing it on the charger. If the charging port is blinking red, this means there is an issue with your battery. There's a way to combat this and possibly fix the issue by manually charging the battery. If your robot is already assembled, then you can skip this next step, but if it is not, you want to take the brain of the Vex IQ, a wheel with an axle attached to it, the battery, connector cables, and a motor. Start by placing the battery into the Vex IQ brain. Then attach the motor to the brain by connector cables. Lastly, take an axle with the wheel attached and place it into the motor. Then quickly spin the wheel for about a minute. After a minute, remove the battery and place it back on the charging station. If it is still blinking red after the previously described troubleshooting, you may need to contact Vex IQ support.
Before installing the battery, be sure that the battery has been completely charged. In order to install the battery, slide the robot battery into the Vex IQ robot brain and listen for a click that indicates that the battery has been installed correctly. In order to remove the battery, squeeze the latch at the end of the robot battery and pull it out of the brain. If you are struggling to remove the battery, try pushing on the robot battery from the other end, which should help remove it as well.